Ready? So basically, we have a temporary field telephone wire section of this pair, and it does not hold up to the wind and what have you, so it's served its life. Now we have to replace it with the copper wire and get it all tensioned right. We got to get all the guys adjusted so things don't shift forward or backwards when we tighten it up. So we're going from this pole to the one on the ridge over there, which is kind of hard to tell from this terrain. Actually, you probably should walk up there. Let's go take a look at that. This is a faulty impression. There's a whole nother world in between. Okay, and there we got that rod there. We got underground electrodes all throughout here for the this is the receiving end ground for the antenna overhead. This is some new exercise for me. The hard part is when I go back down, I don't land on my face. I got to do a zigzag like cattle do. There's where it's broken. So we're going to, not the pole on the ridge, but the one down, next one down in the ravine. That's, between the pole we started from and that pole, that's one loading section. Alexanderson antenna is made up of a series of loading sections. So in this case we have 4. And that one will just jump her through because that's for 8 loading sections, which is too expensive right now. Particularly being that a well hole has to be drilled at the base of every loading pole for the underground electrode. Another expensive endeavor. So right now the best we can do is between the Earth and the ionosphere. Seems to be working pretty good. That's the first step. So that's what we got to do. We got to take this wire down and put the new wire up, which is a lot harder than taking the old wire down, particularly being good stuff to scrap at this point. Cut it. Another thing I should point out, that none of this stuff was here. This pole and cross arm, that next one, 3 or 4 of them back up there. When we got here, this stuff was just shambles. So we had to go out into the deep reaches of the desert and find the remains of this stuff and haul it back here and put it back together again. So basically there's two steps with this project. There's you can use this stuff, but instead of going to the store, you got to go out in the desert and hunt and find. There's bits and pieces of this stuff all over out in the Mojave Desert. So first you got to take it all down, pull it all out of the ground, deal with all the smashed remains and bullet holes and everything else, and clean the thing up, and take it back here and put it back in the air. So that's what takes so many years. It's a lot of work. So basically, in that sense, this is a historical reproduction of the original AT&T long lines when it used to be on poles, cross arms, and glass insulators along every major highway in the United States. The average age of the equipment here is 60 years old, maybe some of it going with 70 up to 120 years old. And needless to say, there's two more pairs to go up there. This is just the beginning. So we have it on, we have that project on standby. We have the wire, we have the insulators, but that one's difficult to do without a bucket truck. And in order to go this far with it, we have to replace the ridge pole. It's not really strong enough to hold that many wires, and they're too low to the ground. We got to come up a little bit. So we got the pole, but it's more expensive to dig the hole for the thing than it is to buy the pole. So the outer pairs will probably pretty much terminate down there along the next loading section. And if we go that far, that's a good start, because this stuff can get really expensive. It's not hard to spend $15,000 or $20,000 on any one phase here. Can you see them up there?
Mm-hmm.
Yeah, they're going up to tighten the guy. So to start with, we got to make sure the end of this line is pulled back a little bit to take up the tension when we put the new load of wires up on this section here, because everything's going to want to come forward. So we got to compensate for that.
So it's on the pole with the sign right to the right of the shack.
Yeah, that's the dead end for this section. That's pole 54. Pole 32 is the other end of this section of line. It's got 3 bends in it. One bend is up there at the ridge top. It's probably hard to see. The wires change direction up there, but that's what they do. And then it heads towards town. Oh, I was wrong about that. That's the dead end for the section that goes all the way down in. That's why that dead end is really solid. This dead end is just for going up to this ridge top. And the problem is we can't put a guy in on that, because a guy anchor would be in the middle of a road and somebody would clobber it. So at that point we have to kind of fool around with all the various forces and make sure that that somewhere the dead end force for this section is terminated, and so that's actually down in the wash. I think that's pretty much the description. Okay, so this cabinet is the terminal for the antenna. So the next step now to get this thing on the air, so to speak, on the internet, is we have to build the vacuum tube amplifier and a voltage regulating network and a network to filter out the adjacent channel interference from the Navy submarine transmitter, which kind of wipes this stuff out. And then that's turned into a 600 ohm transmission line impedance, and then it's taken up to the shack. And then the third wire up here is to facilitate delivering the power as well as the signal. So the power will come from the shack and come down here, get regulated, and then operate the vacuum tubes that will serve as the amplifying elements. You can't use transistors out here, and something like this will just get obliterated. So the amplifiers and their filtering and what have you networks will go in here, and the power networks. So the cavity will start to fill up. So at any rate, to start this whole tensioning process, we secured the guy up at the hilltop. And so now these have been left in a state where the pole is bent back a little bit. And this guy is deliberately a little loose, so that when we load this thing up with about 200 pounds of tension, then this guy will tighten in this position, and that other one, which is holding this line together, is that one will loosen up a little bit, and then the pole will be straight, and the tension on the wires will pretty much be equalized from the shack all the way to the top of the hill there. So this is all the stuff that has to be taken in consideration when you're building this stuff. Is every time you dead end a conductor somewhere, you have to take that force up. And when you got multiple dead ends, like this multiple loaded antenna, is you got to keep those forces equalized so the intermediate poles don't end up being yanked back and forth. So they stay straight and the wire tension stays even all the way through. So that's one of the more difficult things to engage in. It requires a lot of adjustment and fooling around to get the two wires of equal tension, and that's the process which is going to unfold here shortly. Okay, so it's that. Get him from the other direction and see what he's doing. Well, you're getting ready to disconnect the field telephone wire?
Yep, it's okay. Disconnected on one side.
We're not recovering this field telephone wire, so you can just chop at your convenience.
Okay.
That'll make things a lot easier.
Well, in that case,
Dikorama. Just roll up the the individual spans of the stuff, and I don't think we'll throw it away. It all depends how much of a pain in the ass it is to deal with.
conductor coming down.
See, now, put this, look at the next pull down here, and I'm going to say something about what we're doing here. So normally you can't get away with doing what we just did, because now there'd be a dead end load on that pull with pin insulators and no guy, and the whole thing would pull over. But this field telephone wire is so lightly strung that we don't have to really worry about that happening. So we can cut corners. Otherwise you got to go and first run is you got to go up every pole and untie the wires from the insulator and then cut it loose. And sometimes you have to make sure it doesn't get tangled up with other cross arms on the pole, like one's carrying power. So, but this is simple here. So that shortens all this, is the fact that this was just temporary wire and no real tension on it that we have to deal with that makes it dangerous or destructive to hardware. Okay, I think that wraps it up, at least for what I have to say.
Yep. All right, so you can see here we have this spool carriage that we built some time ago. What we're doing is getting these spools of hard-drawn copper set up. Each one of those spools is about 146 pounds. It's like 0.83 of a mile, something like that. So we're just getting this set up so that we can drum out 2 lines simultaneously out the back of my truck and carry them over the cross arms down the line to replace this existing field telephone wire, which has since failed. So it's kind of the operation.
Okay, you can see the 2 reels of wire on the truck.
Where did it go? Right there, yep.
So they're strung up on the cross arm, and then in the other direction is the ends of those 2 wires out there with Justin and Connor.
Okay.
So the two ends of the pair of conductors, is they have those. So they're going to mechanically terminate them to that dead end cross arm, and then they're going to electrically connect them to the rest of the line, and then that will be mechanically and electrically secured. And then back here, then the tension's taken up to about 100 pounds or so on each conductor on that dead end cross arm, which is being taken up by that guy that was loose. And then the final step is to go back from pole to pole. Can you get a shot of this pole here without the sun glare? Losing audio.
Okay.
Like, get the insulators and the wires right at the cross arm. So they're strung loose now, but once they're tightened up, then the conductor gets tied to the glass insulator. That's the final step. And then the field telephone wire replacement job is complete. Well, no, there's one more step. It has to be electrically connected at this end. That's the final step. So this might go into tomorrow morning. I don't know. I still got a lot of angle on the sun. We'll see how it goes. So actually now you want to walk down there and you should be filming the details of what they're doing. If you can get down there.
All right, there you go.
You want to explain the process here?
So what we're doing is we replaced the section of field telephone wire. What we had initially put up was this field telephone wire, which I think is a steel conductor, and it theoretically should have been able to support itself in span, but there might be something wrong with this wire. We got this wire salvaged, and sometimes when you get things that are salvaged, it's because they've been discarded for a good reason. So what we found is that this conductor is not sufficient for our purposes for whatever reason. Either it's not capable of holding itself in span, or it's actually been damaged before we got it such that it breaks. So we had still an electrical connection, but you can see this is a twisted pair. I don't know if you can see that, but it's actually two wires in one. And so one of these along the way, a couple spans back, had broken. And we still had our antenna, was still functioning, we still had an electrical connection, but it was only a matter of time until the other one broke, and then we wouldn't have an antenna anymore. So what we're doing is we're preempting that problem. We're doing a structural repair, and we're putting in this hard-drawn number 10 copper, which was purchased for this purpose. And this is just the last section of that failed field telephone wire that needed to be replaced. So what we're doing is we've pulled this up from Connor's pickup. We'll show that at the other end with the spools in the bed of his pickup truck. And we've pulled this up to this point, terminated it. This is a structural dead end. And then we're going to go back over to the other side and tension this up, put the proper tension on it.
So now that it's secured on this end, what's the next step?
So now it's secure on this end. We're going to go back. We'll walk down the spans here and tension up, just pull the wire out of the bushes. We'll go back over to the terminal cabinet pole, and we'll pull back from that location, tension these conductors up to the tension that they're supposed to be. That's all you get. You can get that.
Yeah, that's good.
Wire looks really good. Here it's all glistening in the sun.
The tie downs are hanging on the cross arms on the next pole, right?
You know, if you use the spool insulators as pulleys, I don't even think we need the come-alongs.
What do you mean, like the opposite spool insulator?
Well, you know, well, I guess you can't do that.
I got the grip here.
Well, yeah, if you put the rope of the grip through the spool insulator to use as a pulley, because we don't really want any more than like my body weight. Over here, no hard hat. Sitting underneath the pole. If you've got the crescent wrench, keep them sailing down on your head.
So, Eric, in regard to tension, how does this look to you?
Oh, well, once you hit one of the wires. Yes. Now shake it around, see what the flop is.
Give me a moment. I'm trying to extricate my gloves.
I'm having a very hard time seeing the wires in the wrong angle.
All right, balance test again. Boom. Boom.
I can't see it.
Return.
I'm shaking to get to the end.
Return. Return. Return.
Yeah, it's a little loose. Just shake it around. How much does it want to flop? No, I mean with your hands. Actually shake it around.
Pretty loose still.
Yeah, that's too much.
Okay.